Alright, so now we're doing the sensitivity analysis. So if the price for crop 2 is fixed, and remember our profit function was f of xy or p or whatever equals 40x plus 60y. So we're saying crop 2 stays the same. So we're still going to have the 60y, and then what will the range of prices on crop 1 still give us our optimal solution, which was this point here, right? So 180.20 was our optimal solution. What values for a price for X, crop 1, will maintain that as our optimal solution? So step 1 is we first plug C in, so P equals CX plus 60y. Alright, so step 2 was to get the slope of this, so we need to get in y equals form. So I subtract cx from each side and get p minus cx equals 60y. Get the slope, so I divide by 60, and that gives me y equals negative c over 60 x plus p over 60. So my slope is negative c over 60. Sorry, it's not a very good color on the screen. Negative c over 60. Now that slope must be between, this is the step 3 I wrote in class, that slope must be between the slopes of the lines where the best point is, alright, where those constraints meet. So it's the constraints, the red and the blue, or whatever numbers you label them. So it's the red and the blue that meet at our optimal point. Alright, so I need to find the slopes of each of these lines. So for the slope of the blue constraint, which had to do with the capital, we are going to have this, so x plus 2y is less than or equal to 220. I'm going to subtract x from both sides because I like to keep the y's positive if possible. 2y. And we only care about where the lines meet, so whether they're shaded on the left or the right doesn't really matter. So you can just treat this like an equal sign when you're solving this part here, because it doesn't matter the shading, we're just looking right on the edge, right on the line. So we got that equals negative x plus 220, divide by 2, and we get y equals negative 1/2 x plus 110. Now, for the other equation, that's pretty easy. You got x plus y equals 200, subtract x, and we got y equals negative x plus 200. So here, our slope is negative 1, and here our slope is negative 1/2. Right? So negative 1 is less than negative 1/2. So what we want to solve is our slope for our profit function, manipulating the price on crop 1, so the coefficient of x, that slope has to be greater than negative 1. Negative c over 60 has to be greater than negative 1, and then negative c over 60 also has to be less than negative 1/2. So we solve these inequalities. I multiply both sides by a negative 60. You get it, multiply by a negative 60. Negative times negative is positive 60. Because I multiply by a negative, I got to switch the inequality. That gives me c has to be less than 60. Multiply both of these by negative 60. That cancels the negative and the 60. Multiply by negative 60. That becomes a positive. And 1/2 times 60 is 30. And I have to switch the inequalities. So c has to be greater than 30. What that tells me is that really c must be between 30 and 60. And c, you remember, stands for the price of crop 1. So the price of crop 1 must be between $30 and $60. All right. If it's not, that will change our optimum point.